Can you find the value of this long expression? This problem might seem impossible at first, but once you use the difference of squares formula, it becomes a piece of cake. Just watch. First of all, we'll have to make a key observation on our problem. Notice how each part of this expression is in this form, where n is a positive integer. The next step is to rationalize the denominator of this fraction to remove these annoying square roots. We can multiply both the numerator and denominator by its conjugate to do so. A conjugate is basically the same expression, but we flip the sign from a plus to a minus. The value of our expression remains unchanged, so we can rewrite our expression like this. We can now use our difference of squares formula in the denominator. Take a equals to root n and b equals to root n plus 1, and we can rewrite our denominator like so. This is equivalent to n minus 1, which is just negative 1, thus making the numerator negative. Here's a cool math trick you might not know. Negative a minus b is equal to b minus a. Using this, our expression can be rewritten as root n plus 1 minus root n. Now, using our newly found formula, we can rewrite this complicated expression. For example, the first fraction can be rewritten as root 2 minus root 1, the second fraction as root 3 minus root 2, and so on, till root 100 minus root 99. The next step is super satisfying. Notice how root 2 cancels out in this expression, so does root 3 and root 4. Using this trick, we are able to cancel out all terms from root 2 to root 99, leaving us with negative root 1 plus root 100, or just root 100 minus root 1. This equals to 10 minus 1, which is just 9, and that's our answer. In summary, we first found a general formula to rewrite each fraction in our expression. After doing so, we cancelled out almost all the terms in our expression to get root 100 minus root 1, which we simplified to 9. As always, I hope you enjoyed this video and see you all in the next one.